Afternoon to everyone. So in yesterday we have studied about ion exchange resin, right? So we'll continue that topic. So in yesterday class we have studied what is its definition, types, and what is the mechanism of ion exchange resin, right? So mainly we are having two types: cationic ion exchange resin and anionic ion exchange resin. So that is depends upon which functional group is attached to the cationic or anionic drug. Okay, so for cationic drug, if it is sulfonic group or carboxylic group is attached, mean that is called as cationic ion exchange resin. If the anionic drug is attached to a quaternary ammonium group or polyalkyl group, means it is called as anionic ion exchange resin. Clear? And that further classified into four types, depends upon the acid and basic quality. Okay, so next we'll move. So what are the important properties of ion exchange resin? The first is particle size and particle form. Okay, the rate of ion exchange reaction depends on the size of the resin particle. Okay, so if it is very small or if it is very large, so depends upon that, the whatever the release quantity or the release kinetic will be there, right? So it will be depend. Decreasing the size of resin particles significantly decreases the time required for the reaction to reach equilibrium with the surrounding medium. Okay, so nothing but, so we are preparing the beads, right? The resin and drug complex we are making, then we are making into a small spherical beads, right? So if that bead what size will be very small, okay, so then what happens, so it will acquire more surface area and also it can easily absorb the water. Okay, so then the whatever the drug will be there, right, it will be diffuses out. The first displacement will occur with the counter ions and it will start to release the drug, right? So it will take very least time. Okay, so that's what. So if we are having the very small what bead structure will be there, means, so what happens, it will reaches the equilibrium and it will start to release the drug in a very least time. Okay, so if it is having more size, okay, so very bigger molecule will be there if you are making, means it is also problem, right? So it will take more time to reach the equilibrium and to diffuse the drug from the resin matrix, right? So that's what. So we need to make a proper and optimum size and also form. So most of the ion exchange resins are available in the form of spherical beads. When the beads are immersed in a water, so they imbibe a limited amount of water to form a homogeneous gel-like structure. Okay, ion exchange resins have hydrocarbon network to which ionizable sulfonic acid groups are attached. Okay, so in case of what, cationic, okay, the hydrogen ions are completely dissociated in the imbibed water and are free to diffuse throughout the entire resin bead and hence can be exchanged for an equivalent amount of ions of like charge. So this is an example for what, cationic ion exchange resin. Okay, what they are given, so hydrogen ions and sulfonic acid group. Okay, so just particle size and form you have to write what it is. So it is mainly depends the what, the release kinetic. Okay, so if the decreased size of resin particle will be there, means it will decreases the time required for reaction to reach the equilibrium. Okay, so if the bigger particle will be there, means it will take more time to reach the equilibrium. Okay, and we are making in a spherical form only. Okay, so that is what you have to write in a particle size and form. Clear? So next is second, porosity. So porosity is nothing but, so it is the porous nature of the particle or beads, right? So what it is defined as the ratio of the volume of the material to its mass. The limiting size of ions which can penetrate into a resin matrix depends strongly on the porosity. Okay, so if it is very porous materials will be there, resinous matrix will be there, means what happens, so it will absorb the more moisture and easily whatever the drug will be there, so it will cause displacement and releases, right? If it is non-porous means what happens? It will sorry, so porosity. So if it is non-porous means, so it will acquire very limited amount of water and it will take more time to release the drug. Okay, if it is non-porous means it will not acquire water itself. Okay, so that is what porosity. Swelling. The swelling behavior of the resin has a marked effect on the release characteristics of a drug resinates. The amount of swelling is inversely proportional to the degree of divinyl benzene cross-linking present in the resin. Okay, so nothing but we had to get to know what is the swelling index. Okay, so first, so if for normally, so whatever you are preparing, right, cationic or anionic, so it contains that polymer divinyl benzene or styrene divinyl benzene. Okay, so that backbone will be there. Okay, so that polymer, so if you want to make a what matrix resin drug complex means, it will cause cross linking only. Okay, so whenever the polymer is mixed with any of the particle, polymerization should occur means there it will cause cross linking of polymer chain. We had to make a very long chain of divinyl benzene, right? The polymers, the series of polymer chain we are making, so that containing any one type of function group, and that whole chain is connected to or complex with the drug particle. So this is what the resin and drug complex, right? So to make a long chain, so cross linking should occur, polymerization process should occur, right? The degree of cross linking, if it is high, okay, so if it is more means what happens, the swelling capacity will be low for a bead. Okay, if degree of cross linking will be very least will be there means, very low will be there means, what happens, swelling capacity of beads will be high, it will absorb more water. Okay, and whatever the drug particle will be there, so it will start to diffuse out. Okay, so that's what. So first, before we are making the beads, so we have to get to know what is the swelling index proper. Okay, so that is what you just have to write, the amount of swelling is inversely proportional to the degree of divinyl benzene cross linking. Okay, so next, ion exchange capacity. It is expressed in the term of milliequivalents per gram of ion exchange resin. The exchange capacity may limit the amount of drug that may be absorbed on a resin, and hence the potency of a complex. So it is nothing but, so on which function group you are attached to particular ion exchange resin and how many quantity you have attached. Okay, so how many equivalent to that drug you have attached, depends upon that the complete resin capacity will be there. Okay, cross linking, so degree of cross linking affect swelling, so same thing I have to write the swelling, so it is inversely proportional to the cross linking, degree of cross linking. Next, acid base strength, it is depends upon the pKa value. Okay, next, the resin ion exchanger should be stable, pure and free from toxicity. Okay, so it should be very pure, stable in all the environment, the complete GI tract, and free from toxicity. Okay, so these are the main what properties of ion exchange resin. Okay, so particle size and form, porosity, swelling, ion exchange capacity, cross linking, acid base strength, and the purity, stability, and so intoxicity. Okay, so these are what the properties of ion exchange resin. So next, preparation of drug resinates. Just briefly we will get to know how we are preparing the drug resinates. So first, drug loading we are doing. Okay, so drug loading means drug complex. So how we are going to add the drug to that resinous chain. Two process will be there, column process and batch process. Okay, so column process means a highly concentrated drug solution is eluted through a bed or column of the resin until equilibrium is established. Okay, so I hope you have studied chromatography technique, column chromatography, HPLC you have studied, I hope. Okay, so in that you know how the elution will be taking place, the columns will be there with a different number. So in that we are making to pass this solution, so to until it will reaches the equilibrium, it will be load the solution. Okay, so like that, here we are loading the drug to the resinous chain. Okay, so that is column process. Batch process, it is nothing but, so with the manually in hand itself we are doing this batch process. Like the resin particles are stirred with a large volume of concentrated drug solution. So manually or mechanically, just we are going to stir this drug and resinous solution in a high speed. Okay, so after this drug loading is completed, so we got the resin drug complex. Okay, so after that what we have to do, the drug resin is then washed to remove the contaminating ions and dried to form particles or beads. Okay, so after the complex we have to wash, okay, to remove whatever the toxic material, whatever the foreign materials, and also whatever the extra ions will be there, so that we have to remove, and it should be dried to form a beads. Okay, spherical beads or particles. If you're making a very powder form, is in which form you want, right? So that form we have to get after drying. So next, the release rate can be further controlled by coating the drug resin complex using microencapsulation. So we know that what is microencapsulation. Just we are going to coat the material with coating material, right? So if you want to ion exchange resin, itself it acts as a controlled drug delivery system. It will delay the drug release. Further, we have to delay the rate of drug release, means we can go for coating system. So that is by microencapsulation. Okay, the coated and uncoated drug resin complexes can be mixed in certain ratio and can be filled into capsules with excipients or suspended in a palatable flavored vehicle containing suitable suspending agents. Okay, so we can make a beads, and that beads can be filled into a capsule by adding some of the flavoring agent. Okay, okay, so or else if you want to make a solution form or the emulsion or the suspension form is also we can make by adding the, sorry, for this we can add the flavoring agent. For beads we cannot add flavoring agent. Okay, so or else we want to make a tablet form. Okay, so ion exchanger is in tablet. If you want to make, means we have to prepare first granules. After making granules we can punch into as a tablet. Okay, the release of drug from uncoated resin beads is expected to begin immediately, while release from the coated form would be delayed, giving sustained effect. So that's what, if coated beads will be there, micro encapsulated beads will be there, mean it will take more time and it will sustain the rate of release. If it is uncoated will be there, means compared to dissolution drug delivery system, diffusion drug delivery system, ion exchange resin drug delivery system is very easily or very fast release system will be there. Okay, so that's what normally we are going for the coating system. So that's what. Okay, I hope you understood. So next, last is application. So what are the application? So mainly in a pharmaceutical industry we are using this ion exchange resin complex for taste masking. Okay, so very bad taste will be there, means so we'll go for this technique, taste masking. Example, we are having that indion. Okay, so that is one type of ion exchange resin. Indion we are using for taste masking, to eliminating polymorphism, improving the dissolution of poorly soluble drugs, to improve the stability, to improve the physical characteristic. Okay, so these are the some advantages and also applications you can write. So which are type of drug delivery system will be there, means we can obtain in form of oral drug delivery system, nasal drug delivery system, drug delivery system, and ophthalmic drug delivery system. Okay, so these are the advantages of ion exchange resin. Okay, that's it. Okay, thank you.